All right, so we have 3 different categories. We'll look at 2 types of statistics, also population and sample, and then observational study versus design experiments. Basic vocabulary, but we're going to learn how to manage within the context of different studies. So descriptive statistics are methods for organizing and summarizing information. Organizing and summarizing information. I actually have an example for you. So wait, that doesn't work. Not sure how this is going to work out. Jenna, can you read for us about the 1948 baseball season?
In 1948, the Washington Senators played 153 games, won 56, and led the 97th. They finished 7th in the American League and were led in hitting by Bud Stewart, whose batting average was .279. Baseball
Statisticians.
Compiled these and many other statistics by organizing the complete records for each game of the season. Although fans take baseball statistics for granted, much time and effort is required to gather and organize them. Moreover, without such statistics, baseball would be much harder to follow. For instance, imagine trying to select the best hitter in the American League given only the official score sheets for each game. More than 600 games were played. In 1948, the best hitter was Ted Williams, who led the league with a batting average of .369.
Well done. Thank you. So, descriptive statistics simply gathers information and shares it. Okay? So there's your baseball example. It does include the construction of graphs, charts, and tables. I remember when I was younger, and we would follow. My sister was more into the Reds than I was, but every day when we would get the newspaper, she would flip to the sports section and check. They would have these charts, and it would tell where did we rank after yesterday's game, and all of that was based on specific data collected by statisticians. That's a job, a Major League Baseball statistician. There's lots of opportunity out there for you, future statisticians, and tables. Given that information within descriptive statistics, we're actually calculating measures such as averages and measures of variation and percentiles. Averages, do you know how to find an average? Hopefully we do. However, measures of variation and percentiles are topics that we will discuss more in depth in units 2 and 3. Next, inferential statistics. So inferential statistics, within that hopefully you see the word inference. So you're kind of making an assumption in inferential statistics. And that would be the methods for drawing and measuring the reliability of conclusions about a population based on information obtained from a sample or a population. So, for example, we have the 1948 presidential election. So, back to the era. 1948 presidential election. Can someone read this for me, please? Thanks, Corey.
1948 presidential election. In the fall of 1948, President Truman was concerned about the statistics, the Gallup poll. I'm sorry.
It's okay.
Taken just prior to the election predicted that he would win only 44.5% of the vote and be defeated by the Republican nominee Thomas E. Dewey. But the I'm sorry, I can't say words.
Statisticians.
Statisticians
It's still tough for me.
I predicted incorrectly. Truman won more than 49% of the vote, and with it, the presidency. The Gallup organization modified some of its procedures and has correctly predicted the winner ever since.
Thank you. Based on information in a survey, the Gallup poll made an assumption. Therefore, you have an inferential statistics. They didn't do a vote of everybody that would be voting before the actual vote. They just don't do that, right? So they had to survey a smaller group and make an inference. It's kind of neat to know, though, that they do such a good job of predicting the results. So when you think about inferential statistics, that's when we have this sample versus a population. And a population is the collection of all individuals or items under consideration in a statistical study. So in the case of the election poll, the population is actually all voting age citizens, all voting age Americans. So you can put that in here. All voting age Americans. The sample then would be the part of the population from which the information is obtained. So that smaller group, as you can see in the picture, I think that's a pretty good visual of the population, larger versus the sample, smaller. In the case of the election poll, the sample is those surveyed in the poll. Those surveyed in the Gallup poll. Those surveyed in the Gallup poll. All right, so we have descriptive and inferential statistics, population and sample, and lastly we have observational study versus design experiment, which goes back to the cell phone, which I call social experiment, but in reality, we'll find out what it is. Observational study, researchers simply observe characteristics and then take measurements, as in a sample survey. Ooh, blank was too small. Measurements. So someone is collecting data that already exists. So we could give an example here of the cell phone study. Was actually an observational study, right? They had some stealth stalker go out and just watch people as they interacted and then gave them a survey to give feedback based on information they already had. They had already made decisions about how they felt about their interaction with the person sitting with them with the cell phone out. A design experiment is where researchers actually impose treatments. So researchers impose treatments and controls. Right, so this kind of goes back to what you talk about in science class. Researchers impose treatments, and then they also make sure there are controls in place. Nate?
So would an example of that be like a doctor giving a patient new medicine?
So that would be like maybe a smaller version. A true designed experiment would be maybe where they're doing a drug test. So they're actually experimenting to see if like a new drug on the market works. So maybe a new sleeping pill, and they would have 1,000 people, and 500 of them take the sleeping pill, and 500 of them take a sugar pill that looks just like the sleeping pill, right? So they don't know if they're taking the sleeping pill or not. So that would be in that realm, a design experiment.
Because I figured it would just be like that because like if a doctor is like controlling like how much like the patient gets, just so.
Yeah.
overdose.
Small level, yeah. Sure. That's kind of like you're kind of experimenting with how much to give that patient in particular. But when we talk about designed experiment, we're talking more on the bigger scale picture. Corey?
I was just gonna like give an example that you
Okay.
already gave.
Okay, cool, thanks. So then afterwards, they observe the responses and take measurements. So an experiment actually establishes a cause and effect. Were you gonna guess that? Cause and effect. The data doesn't actually already exist until someone does something. Someone actually performs that experiment that produces the data. So, kind of a major distinction here. Observational studies can reveal only association, whereas design experiments can help establish causation. Causation is not a word we use all the time. But it is a word that we use pretty frequently in statistics. So causation just indicates cause and effect, all in one word.